All right, so today's lesson, we're going to be solving quadratic equations again. And we know different techniques like the quadratic formula or factoring. And so this is another technique that we're going to learn. But before we do that, I want you to look at these two equations right here. And before you think about, oh, should I use quadratic formula or should I try to factor it? There's something different about these two quadratic equations compared to all the other ones we've looked at so far this year. And that is the different terms or different variables in here. First off, are these both quadratic equations? What's the one thing that makes an equation a quadratic? X squared. Exactly. Do these both have an x squared in them?
Yes.
They do. Therefore, they are quadratic equations, right? If the biggest exponent is a 2, it's a quadratic equation. But what's missing from both of these? Yeah, the x term. There's no x to the first. Is that okay?
Yes.
Yeah, that's fine. It's still a quadratic because of that x squared term. But since there's only one variable in both of these equations, there's just a single x. Could we use just like basic algebra to get the x by itself?
Yes.
Like think old school algebra 1. If I gave you this equation on the left, x squared equals 12, and I said, hey, get this x all by itself on one side, well, what would you do to get rid of that exponent? Just square root, right? Wouldn't this be the easier thing to do than to get out the quadratic formula, like standard form, this and that? If I just square root this, the x squared cancels out, and I'm left with just x equals, and then I've got this square root of 12, and I could just simplify it. And that's my answer, isn't it? X is by itself. Isn't that easier to do? Instead of having, and I can only do this if there's an x squared term only. If there were an x squared and an x term, I can't combine them because those are unlike terms. But if there's only an x squared, I'm just going to use old school algebra to get it all by itself. Now, there's a few more things I can do here with this problem on the left. I have x equals the square root of 12. Should I leave my final answer like that?
No.
No, what should we do?
Just take a 4 out of it.
All right, let's break this down. That's 4 times 3, and what is the square root of 4? So this is actually 2 root 3. So that's my solution, x equals 2 root 3. And there is one more piece of this, but we'll get into that in a moment. But for the most part, that's how you should write your final answer, simplified radical form. Over on the right, shoop. So what should we do first to the right side?
Subtract the 5.
Yeah, get rid of that 5. That leaves us with a 3x squared equals 75. Now what do we do?
Divide the 3.
Is this pretty easy? Do you think you can all do this on your own? Yeah, it's a piece of cake when there's only an x squared term, isn't it? It's just like regular algebra. How about this last step? Square root. So what does x equal?
5.
5. What do you think? Is that easy enough? Yeah, it is. Now, we couldn't do this with our other types of problems when it was in standard form, for example, because there's an x squared term and an x term. And I can't combine them because they're different numbers, different values. But if there's only an x squared term, by far the easiest thing to do is just cancel stuff out using old school algebra 1. Now, when we use this technique, though, for both of these problems, how many answers did we get? 1. How many answers do we typically get when we solve a quadratic, though? Don't we normally get 2? For like the 2 places where our parabola crosses the x-axis, right? It typically crosses twice. Sometimes it could be just 1 if the vertex is right on the x-axis, but that's not too common. Why do I have only 1 answer there? Is there another number that I'm missing?
Well, the other answer is 5, 2, 4.
What's that?
Isn't it like only? Or no, sorry. I know why.
Okay.
I can't. I'm trying to think of it.
Okay. There is something that we need to be aware of here. And first off, let's look at the problem on the right. That's a bit simpler to work with. Is 5 actually the solution to that original equation? If I plug 5 in for x, would it work? Yeah, if I put a 5 here, what's 5 squared? It's 25. What's 5 times 3? And then what's 75 plus 5? It's 80. So yeah, 5 definitely works. That makes it true. And in fact, as long as this number here is a 25, it's going to work, isn't it? So is there another number that we could plug in for x right here on this line? X squared equals 25. If this were my only equation, we're trying to solve this, find the solution to that equation. I want to think, hey, what number that when I square it, I get a 25? Well, obviously 5 works. But is there another number that we could square to get a positive 25? How about a negative 5? Would that work, first off? If this right here were a negative 5, would we get the same answer? What's negative 5 squared? Positive 25. 25 times 3 is 75, and 75 plus 5 equals 80. So negative 5 would also work, wouldn't it? Sure would. And that's going to be true for most of these. In fact, anytime you're solving a quadratic equation where you have to take a square root of the variable to solve it, we're not going to get just one value. We're going to get 2. So right here, this step, I'm taking the square root of both sides to get the x by itself, to cancel out its exponent. Instead of just writing a 5 down here in the last line, we're going to write this. Plus or minus 5. Both of those will work. Those are both valid solutions to my original problem. And now, how many answers do we have? Is that what we should have gotten, what we expected? Yes. So x could equal a positive 5 or x could equal a negative 5. Shyla? To solve an equation for x, yes. If you've got that variable squared, whenever you're square rooting to get the variable by itself, you want to take both the positive and the negative version of that number into consideration. They both could be it, because both 5 and negative 5 squared would equal positive 25. So that's 2 options. Now, if you type this into your calculator, the square root of 25, what number are you going to get? Just 5. Right? The square root by itself will always return a positive number. It'll never give you the negative. So we, as intelligent humans, have to realize, wait a minute, a negative would also work here. But the calculator doesn't do that. The square root operator itself always returns a positive value. So we have to know, oh, it could be negative also. Which means over on the left side, is our answer 2 root 3? We have to put that plus or minus. It's a positive 2 root 3, but also a negative 2 root 3 would also be a valid answer, okay? So for all of these types of problems here, when you're solving for x and there's just an x squared term, make sure that whenever you take that square root, you put a plus or minus in front of it. Also, something, just a little side note before I continue on with the lesson, you don't need to write this down. In our quadratic formula, what comes after the negative b? Plus or minus a square root. You ever wonder why there's a plus or minus in front of the square root? That's a weird symbol, right? But now, do we know why? Why does there need to be this symbol? Because when you take a square root of something, you have to consider both the positive and the negative version of it. So that right here, this reason of these, square rooting of variable, you get those positive and negative options. That's why there's that plus or minus in front of the square root in the quadratic equation or the quadratic formula. Carlos goes, is that the whole lesson? No, here's the title page of the lesson. We got through the warm-up. Don't worry, it's still a pretty short lesson. So our final technique is completing the square to solve quadratics, to solve a quadratic equation. So we're going to do it by completing the square. And you should recall completing the square from our first lesson in this unit with that vertex form. Remember when we had equation in vertex form? We converted it, or in standard form, we converted it to vertex form by completing the square. That's when we had to like add the magic number. Remember the magic number, right? Half of b squared, add it to both sides. And so if I look at that quadratic equation at the bottom of the screen, we've got x squared plus 8x plus 16. Now, because there's an x squared term and an x term, I can't just solve it using basic cancellation, right? Basic algebra 1, because x squared and x are two different numbers. They represent two different values. And so I can't combine them just by subtracting or dividing or whatever. What we're going to do, though, is we're going to change this form essentially into vertex form in a way. I'm going to complete the square, because when you complete the square, you get, instead of two different x's at two different places, you get a single x, which is great, because if there's just a single x in my equation, then I can use basic algebra to cancel everything else out to get the x all by itself. So let's try this together. X squared plus 8x plus 16. I essentially want this to be x plus 4 squared. Those are equivalent. This is what we would call vertex form. I just recognized that half of b squared is a 16, meaning this already is a perfect square trinomial on the left. If it is a perfect square trinomial, I can write it in this form. Now, if I look at this form here on the right, physically, like how many different x's did I actually write? There's just one of them, right? There's only a single x here. So if this part in green, if this were my equation, could I solve that for x pretty easily using just basic algebra? Like if I wanted to get this x by itself, what would I do first? Can I get rid of this square easily? Square root it. Can I get rid of this plus 4 easily? Subtract 4. Then the x would be by itself. So that's what I mean by writing it in this form. Because then if I have only one x, we can use just your basic cancellation properties to solve. And that's what we're going to be going through today. So we're going to solve this equation by completing the square. And so I just put the note up here that this is in standard form right now. We don't want it in standard form. We want this to be written in vertex form, essentially, because in vertex form, just like that last example I just showed you, there's only a single x in our equation. Here, there are two x's. There's the x squared, and there's the x just to the first power. So this is going to be a nice little refresher from Target 5.1 on converting it to vertex form. Are you ready? Here we go. So first, we need to complete the square to get this in vertex form. What I'm going to do is get rid of that constant, right? That's negative 13. How to get rid of it? We add it to both sides. Now, I'm going to show you one thing that's a little bit different here. Because we're actually solving, if it says solve, as opposed to just rewrite it in vertex form, I don't care about this y. If it says solve, what number should I plug in for y? Good, that's right, a 0. So to make this easier, I'm going to rewrite this as 0 equals x squared minus 12x minus 13. Now the nice thing about that is now when I add 13x to the other side, not 13x, goofy. Here we go. I'm just going to have 13 equals x squared minus 12x. So it's a little bit nicer because I don't have that y on the left side, which we did when we were trying to keep it in that vertex form. In this case, we just add that to the other side. So now I've got x squared minus 12x, and we need to add the magic number. What is the number here that would make that a perfect square trinomial? Awesome. So just to recall, C, the magic number, to calculate that, you take B, the linear coefficient, you divide that number by 2, just cut it in half, and then square it. Is that familiar to everybody? Hopefully. That's just from the last learning target. And so half of negative 12 is negative 6, and negative 6 squared is positive 36. But hey, if I add 36 to the right side, to keep the equation balanced, I have to add 36 to the left side. So I'm going to add 36 over there on the left. Ooh, those are some good math skills. So 49 equals, now on the right side, this is now a perfect square trinomial, meaning I can write it as a single binomial being squared. What's going to go in these parentheses?
X minus 6.
It's always just going to be half of b, right? Whatever we squared for it. The opposite thing you're thinking about is if we were to graph this, this would be shifted 6 units to the right, right? That's when you flip the sign, if you're graphing it, comparing the graph to the equation. All right. Now, normally, if we were just writing it in vertex form, at this point, I would subtract 49 from both sides. But stop. That's not what we're going to do here. My goal for this, remember, was to solve the equation. To solve means to get the x all by itself. So right now, that x is on the right side. I'm going to leave it there. I want to get rid of everything else on the right side and move it over to the left. So I see a negative 6 and I see a square, an exponent. I need to cancel those out. How do I do that? What should we do first to both sides of this equation? Do I get rid of the negative 6 or do I get rid of the squared first? Yeah, because that's like the outermost thing. I've got to cancel out that square before I can get into that negative 6. So how to get rid of a square? And if I square root one side, I have to square root the other side. So by doing this, the square and the square root cancel out. And I'm left with just x minus 6. We've almost got x by itself, don't we?
Yes.
What do I write on the left side? Ooh, 7 or plus or minus 7. How many answers do we get when we solve quadratics? 2. Right now, we solved for that variable, for that x minus 6 squared. We're solving this equation by using a square root. We need to put that plus or minus in front. Because if x minus 6 equals 7, or if x minus 6 equals positive 7, right, this piece right here, if this piece were a 7 or a negative 7, when we square it, we'll still get a positive 49. So that's why we take both positive 7 and negative 7 into account. What's my last step to solve this equation for x?
Make the 6 go over to the side.
That was very elementary. Good job. We're going to add 6 to both sides. What happens on the left, though? Yeah. Don't we expect to get 2 answers for the most part?
Yes.
Just remember, this is saying that it could equal a positive 7 or a negative 7. So all you do is add 6 to each of those numbers separately. Yeah.
Negative 1.
So if I added 6 to a positive 7, well, 6 plus 7 is 13. So you could say x equals 13. If I added 6 to a negative 7, what do we get? Negative 1. So that's the only kind of weird piece to solving these quadratic equations this way. If you take the square root, you've got a positive and a negative number. We do still get 2 answers, just like if we factored it. Or if we use the quadratic formula, we'd get 2 answers. Same thing here, but you just have to think one extra little bit whenever you square root. Now, hopefully you're going to do these so much that you'll know, oh, square root plus or minus, square root plus or minus. All right, that's what I want you to try to feel moving forward. All right, this one, we don't need to set the y to 0 because there is no y in it already. We want to solve this quadratic equation by completing the square. So here's what we're going to do. I guess go ahead and take a moment to write this down. X squared minus 4x plus 6 equals 27.
How do you know whether to do the whole x equals some number or the quadratic?
It's up to you, to be honest.
Okay.
This year, for my intents and purposes, I'm going to test you on each skill separately. I want you to be able to demonstrate each of these skills. But moving forward, you can just use whichever technique you're most comfortable with.
Quadratic formula.
If you are, honestly, the quadratic formula, it might take a little bit longer to do than just factoring, but you'll always get every answer, even if it's an irrational number or an imaginary number, which is why the quadratic formula is the most powerful version of any of these. You're welcome. Dun, dun, dun. Oh my gosh. Stop it. I want to watch Avengers now. Ugh. Okay. So here's a regular equation, and we are just going to solve it by completing the square. We want to move all the constants to the opposite side, right? All I want is the x squared and the x on one side by itself. So let's start by subtracting 6 from both sides. That gives us x squared minus 4x equals 21.
No way.
To complete the square, I need to add this magic number to both sides. What is the magic number?
It is 4.
How'd you get a 4?
Because you take half of your b.
Half of b.
And then you square it.
Square it. And you get a 4, right? I looked at b, which is the linear coefficient. I divided it by 2, and I squared it. That gave us a 4. So we know we have to add 4 to both sides of this equation. By doing that, by adding 4 to both sides, it turned the left side into a perfect square trinomial, meaning I can factor it as just x minus 2 squared in this case.
Like it would be like x minus 2 squared plus 21.
What's 21 plus 4? 25.
Woo! 25. And guess what you do now?
Gosh, golly.
Who would know?
There's no longer an x squared term in an x term, which is great. There's just a single x on the left. Let's get that little x all by itself.
And square root it.
Got to get rid of that square, so we square root both sides. That leaves us with x minus 2 equals
5 plus or minus 5.
Woo! He's got the plus or minus already. That is awesome. That's exactly what I wanted you to be able to do.
Then you just add the 2 over. And you got your big.
And you add the 2. Whoops. But wait, what do you add 2 to? 2, 2.
Plus or
minus 5.
Okay, so you're adding 2
You set up your 2 equations.
to both a positive 5 or negative 5. Yeah, if you want, you can think of this as saying, hey, x minus 2 equals 5, and x minus 2 equals a negative 5. If that helps you for now, you can go ahead and write them out separately, because this is what you're actually solving, 2 different equations. The x minus 2 could equal 5, or the x minus 2 could equal a negative 5. And then by adding 2, I'd get a 7 or a negative 3. And those are your 2
Oh, this is too good.
solutions.
Is that all?
Yeah, but we're going to look at just some more difficult examples in a moment. But this is it. This is the whole lesson. We're able to go from having 2 terms with an x to having only 1 term with an x. That's the whole purpose. By completing the square, we get just a single term with x, and then we can solve it just by using some basic algebra. Maybe, I don't know. Well, we converted it from standard form to vertex form. That was target 5.1. That's what you're thinking of, yeah. It's still the same process, right? That's why you already know how to add this magic number. But they're doing 2 different things. One of them, I just wanted to rewrite the equation in a different form because it's easier to graph. In this case, I want to solve the equation. I want to figure out what does x equal. but we use the same technique for each of them. Yes?
Delta math, there's like a different way of doing the math.
Right. Yeah, absolutely. So if you, I do have a few more examples of doing this, but right now I had a good question about on Delta Math, if you got one of these completing the squares wrong for rewriting it, and it shows you the steps, if you look into them, it adds this magic number piece a little bit different each time. And if you've got a quadratic equation, x squared plus, let's say, 6x minus 5, and I want this to be a perfect square trinomial, and we would get the constant over to the right, so x squared plus 6x equals 5. But now, actually, let me move this over. I want to add a brand new number here. I want to add this magic number to make this perfect square trinomial. And so to do that, it's where we take half of 6 and square it, which is 9. So I want to add 9 here, right? That's the whole completing the square process. But in order to do this, we have to think algebraically. This is an equation, it needs to be balanced. Mathematically, I can't just randomly add in 9 to an equation. So there are technically two options here. There are two things I can do. One of them, and if we think of, I want you to think of this equal sign as like a teeter-totter, right? There's a left side and a right side. They have to be balanced so that it's level. If I added 9, think of it as weight, right? If I added 9 pounds to the left side of the teeter-totter, the way I've been showing you is to keep it balanced. Can I just add 9 pounds to the right side of the teeter-totter? And won't it still be balanced? It's the same thing. So that's what I was showing you. But there's another way we can keep this teeter-totter balanced. If I have this x squared plus 6x equals 5. Oh, let me write this. I still need to add 9 here to make that the perfect square trinomial. But what if, instead of adding 9 to the right side to keep it balanced, what if I subtracted 9 on the same side? Would that still be balanced? If I didn't have those parentheses, which I just showed you that just for grouping purposes, did I change anything on the left side actually? If I add 9 and subtract 9 on the same side of the equation, it'll still stay balanced. If I combined these like terms, that equals 0. I'm essentially adding 0. But instead of writing a 0, I'm writing a plus 9 and a minus 9. Isn't it still the same thing though? It's still equivalent. Now, why would I do that? By writing it this way, I can now write this as x plus 3 squared, and I just have this minus 9 already over here. Now, to make it even easier, is if you're rewriting this, like if this is a y, remember I always said move everything over to the right side, then subtract it? I can leave that as just y the entire time. If I keep the negative 5 here, what if I still had the negative 5? So if I want to leave the y by itself on one side, what I could do is write this as x squared plus 6x plus this magical number 9. And outside of it, I had a negative 5, and I then had to subtract a 9. So see this plus 9 and this minus 9? That's what I just added in right now. And by doing that, I can now write this as x plus 3 squared. And then negative 5 minus 9 is negative 14 equals y. It's already in vertex form. So that's on delta math. It shows you that way. But I think that's still very confusing for students to be like, oh, I'm adding 9 inside the parentheses that weren't there and outside the parentheses. But if you do that, it works out a lot nicer. You know, I've got my vertex at negative 3, negative 14, and a is 1. Boom, let's graph it. So 2 steps. You're welcome. All right, now these are the more tricky problems, the more involved ones. All right, and when this leading coefficient is not a 1, when there's an actual number in front of the squared term, like 2 in this case. We can't complete the square whenever that x squared has a number in front of it. So let's just divide it out. So everyone jot this down, right? Y equals 2x squared minus 3x plus 1. Now we're going to be solving this, so what should I plug in for the y?
0.
For solving, yep, just think of this as like a 0, okay? I want to get the x squared without a coefficient, so what do I have to do? I'm just going to divide it by 2. That'll make it just an x squared, but I have to divide every term by 2. Divide by 2, divide by 2. Even that 0 on the left, I'm dividing by 2. That's still some nice, easy math, because 0 divided by anything is still 0. Now I have x squared minus 3 halves x plus 1 half. Oh, it's fractions. We get to do one with fractions finally. Thank goodness. Don't we love fractions?
So 0 away from decimals.
Yes. I mean, they'll still work if you use decimals, but when you're dividing one of these by half and then squaring it, that's where the fraction is going to be easier to work with than a decimal. But if you want to, if you're great with working with decimals, you may 100% work it out that way. So now let's finish this problem. I want to complete the square. So we get rid of,
Subtract the 1/2 over, please.
you got it, get rid of the constant so that we only have the terms with x's on one side. That's right. And we want to add the magic number. All right, let's do a little sidebar here. I need to take b, which is 3 halves. Right, that's b. I need to divide that by 2 and then square it. Are you ready for this?
Just cancel, please.
To divide a fraction by 2, think about it like this. Dividing by 2 is the same as multiplying by half. Right? If I take half of something, that's the same as dividing it by 2. So all you're going to do is change this.
The 3 over 4.
Just double the denominator. By doing that, you've just divided by 2. Okay, doubling the denominator is the same as dividing it by 2. An easy way for you to think of this, that's so confusing, if you have half of a cake and you divide the half in half, what fraction do you have of the original cake? You have 1/4, right? You have 1/4 of the cake then, half of the half. And so you're really just doubling the denominator. Now, to find this magic number b that we're going to add to both sides, after we divide it by 2, doubling the denominator, we then need to square it. That's also easy. To square a fraction, just square the numerator and square the denominator. Squaring and multiplying by 2 are 2 different things. You are okay.
Wait, what is it?
Remember, that's how you find b, that magic number to make it a perfect square. Divide by 2 and square. So divide 3 halves by 2. I got 3/4. I squared that. I got 9/16. So 9/16 is my magical number. I want to add that to both
That's crazy.
sides.
So now you have to change the 2 to 16.
I know.
That's easy.
It is still easy, right? Yeah, it's fractions, and yes, we have to get a common denominator. Yuck.
Oh, common denominators are so gross.
So gross. But I think we can handle it. So on the left side, I'm taking negative 1/2 plus 9/16. I'm going to combine these. To do that, I want to get a common denominator. I want to make that 2 into a 16. What should I multiply 2 by?
Go with
Multiply it by 8. on the top and bottom, right? Times 8 times 8. That makes this.
You screwed up on that. You got plus or minus.
We didn't square root anything yet,
Oh, yeah.
sir.
So you.
Well, we're gonna do that in a second, so don't forget.
Thanks for the reminder,
You're welcome.
Keegan. That's very helpful.
Yeah.
Okay, can I add those two fractions now? Yeah, that's pretty easy, isn't it?
If you know how to add.
What's 9 minus 8?
Um,
It's 1.
yes.
I'll take care of it for you.
Got it.
So this left side is just 1/16. My right side, by adding that magical number, that 9/16, that made it a perfect square trinomial, so I can write it as a single binomial being squared. X minus something squared. What's the something?
That.
Perfect. 3/4. Nate, that was awesome.
Good job, Nate.
Remember, the number that goes in there is always half of b. b was 3/2. Half of b was 3/4. You just doubled the denominator.
No. You have to square one.
Trust me, that was the harder part. Square rooting right now is going to be easier.
That was the.
Landed.
We want to get the x by itself. So you're right, we square root. And at first, you might think square rooting a fraction, that's impossible. It's not, I tell you. Just like squaring a fraction, you just do it to the numerator and denominator. Same thing true with square rooting. What's the square root of 1? What's the square root of 16?
4.
Was that bad?
Yes.
X minus 3/4. Keegan, what am I missing?
You're missing the plus or minus, and I told you not to forget.
We square rooted. That's when we add in that plus or minus. The square root of 1/16, it could be a positive 1/4 or a negative 1/4. What's the last step here to solve for x? Don't forget. Plus 3/4. By the way, whenever you do this process, it should always work out that this last step, you're already going to have a common denominator to make that last addition or subtraction pretty easy for you.
And guess what?
X equals, what's 1/4 plus 3/4?
1.
It's actually 4/4, right? But that does, of course, equal 1. What about negative 1/4 plus 3/4?
Negative 1/2.
Negative 1 plus 3
Oh, 1/2.
is 2, which simplifies to 1/2. So those are your answers, 1 and 1/2. I know a lot of weird steps, but they're not that bad. You could do each of those things individually. This is just practicing elementary mathematical skills. Maybe middle school. I don't know when you learn fractions. Anyone remember? No?
I think it's like 5th grade. Let's be real.
Questions on this? I think I have one more for you. And you're going to be happy about this, right? Because I'm giving you extra practice. Let's see. Oh! But no, I'm pretty sure it's the last one. Oh my gosh. Okay, 2 more. I'll just work. Can I just work it out with you?
Yeah, of course.
All right. So we want the x's on the same side, don't we? So 3x squared minus 5x equals -2. All I did is I subtracted 5x from both sides.
Divide 3.
Yeah, that 3. Oh my gosh. Can't have that there. So divide everything by 3. Did I really give you more fractions? Gross. Oh, okay, good. X squared minus 5/3 x equals -2/3.
And now we wait.
You don't want to calculate the magic number?
I mean,
I'll bet Nate can do it.
we'll let Nate do it.
What's the magic number?
-5/6.
So close. That's half.
You gotta.
Now square that number,
You gotta
Landon.
5/60.
What's 5/6 squared? 25 over 36.
Let's go, mate. Go on.
So I'm going to add 25 over 36, add 25 over 36.
Oh, and now we need another.
Common denominator. This is so much fun. 3 times what equals 36? Times 12 times 12. So that's going to be a negative 24 over 36 plus 25 over 36.
Equals 136. Woo!
Gosh, that's a nice perfect square. It's like I planned this. Come on. Our left side is now a perfect square trinomial, so I can write it as x minus what squared?
What line is that?
Perfect. Negative 5 over 6 squared. On the right side, we have positive 1 over 36.
And now we do the fun step.
The fun step.
The fun step. The square root of.
Square root, right? I want to get the x by itself. Let's cancel out that exponent. Square root both sides. That leaves us with just x minus 5/6 equals.
1/6. But you can't forget the plus or minus.
Can't forget the plus or minus. No, sir. No, sir. That'd be crazy. Now what do we do?
Add the 5/6 over.
Add 5/6 to both sides. Add 5/6. Those cancel out. And x equals, so start with the positive. What's 1/6 plus 5/6? What's 5 plus 1? Yeah. You had that, right?
Come on, man.
You're just joking. That's a 1.
Carlos is asleep.
Negative 1/6 plus 5/6. What's negative 1 plus 5/6?
4/6.
4/6, which simplifies to 2/3. Good. 4/6, so 2/3.
And that's our two answers, ladies and gentlemen.
1 and 2/3. Pretty groovy?
That's groovy.
Carlos, you got that? Yes.
What was your math?
Remember, these are recorded. You can rewatch them anytime if you missed part of the lesson, if you needed to take a breather or, I don't know, take a nap or something. You can always rewatch them to make sure you get everything. Okay, this is the for real last one.
Okay. I'm not very good with imaginary numbers, so Landon, you can take the lead on this one.
Hey, just imagine you can solve this problem, and you can. All right, everyone, for real, you are going to want to write this down because you will have homework problems that have irrational and imaginary solutions, and I want you to be able to refer to your notes and your example so you can see how we would write this final answer. So 3x squared plus 36x plus 300
Oh, this is simple. You
equals
just divide
0.
the 3.
That's the nice thing about it, starting off, right? This x squared has a 3 in front. We want the x squared without a coefficient, so just divide by it, but we have to divide every term. And gee golly, isn't that nice that they're all divisible? Ooh, it's a psychic. X squared plus 12x. Did you say 300 divided by 3 is 10? No? What is it? Carlos, what is it? 100. What's 0 divided by 3?
0.
Nailed it. Not really.
Subtract the 100.
x squared plus 12x equals negative 100. We want to get rid of that constant.
That's 36.
Got to add that magic number. I'm going to even leave myself with a little room to sneak it in there. It equals negative 100. Magic number, take half of 12, which is 6, square it, and you get 36. I want to add a 36 here. To keep it balanced, I'm going to add a 36 over there. I can now write this as x plus 6. This is great. Really makes me believe that we're learning.
Negative 64, sir.
Negative 64, sir. Wait, was that part of your answer?
Yes.
Get out of here. Not really.
Oh, it's the square root of a negative 64.
All right. I love it. The realization is dawning upon everybody. The square root of a negative.
Negative 1.
Square root, square root.
So it's
The left side, we have x plus 6 equals the square root of negative 64 equals
8i.
8i
Squared.
or
Plus or minus.
plus or minus. That was your job, man.
I told you I was paying attention during that power nap.
Plus or minus
Don't look at me, Roman. I was the one doing all the work. I was carrying this.
8i. Plus or minus because we're solving an equation by square rooting. 8 because the square root of 64 is 8. I because the square root of negative 1 is I.
It doesn't matter the 12 of the points. It's just the one who scores his bugging.
Hey, what is our last step? Yeah, so this is going to look a little weird. We want to subtract 6, and over here we want to also subtract 6. So the way that we would write our final answer here, everybody, and again, you're going to type it into Delta Math this way, is x equals, typically we want, this is a complex number, right? There's a real part and an imaginary part. We always write them a plus bi. So make sure that the real number is first, so the negative 6, and then the imaginary part comes second. And in Delta Math, it does have this plus minus symbol button there for you. So we just write our final answer like this. No, I don't think it'll mess up. If you wrote it like I have one line above, plus or minus 8i minus 6, it should still work. One other thing,
No.
sorry. Just you might see some examples that are also just roots. Remember we had like the root 12? And that like very, very first one, like a plus or minus root 12. So you might have radicals as well as imaginary numbers. So you might write your answer like x equals plus or minus, what was this, 2 root 3. So you might have some answers that look like that with a radical.
That's crazy.
Just so you're